Pulse code modulation. In this assignment, we are required to design a PCM. We need to achieve the objective above. We have 3 objectives. This is our objective. This is our group member, Noliana Atira, Yasira, Nur Shazwani, and Nurul Afika. We will explain about introduction, PCM process component, MATLAB coding question and discussion. This is our introduction. Pulse code modulation is essential analog to digital conversion of a special type where the information contained in the instantaneous samples of an analog signal is represented by digital words in serial bit. In PCM, we have 4 methods. First method is sampling. The first step in PCM is sampling. The analog signal is sampled at equal interval every Ts. The inverse of sampling interval is sampling rate or sampling frequency. Second, quantization. The result of pump is a series of pulse with amplitude values between the maximum and minimum amplitude of the signal with real values. Third is binary encoding. Each quantized sample is translated into equivalent binary codes. This is line encoding. The binary digits are then transformed to a digital signal using one of the line encoding. This is component versus block diagram. MATLAB coding. This is our example 1. We can look, this is close all used to clear MATLAB coding windows. The second one is easy to plot graph using the formula. The third one is label for output window for the graph. Fourth is assign of value of n. Quantize and encode floating points input to integer output. Then, label for output windows for graph figure 2. Third, label for output windows for graph figure 3, plotting label of x. This is our result or output. We can see the graph. We have 3 graphs for analog signal, sample signal, encode signal, decode signal, and square signal. Question 1 is, what is the frequency of the analog signal that has been used in the example 1? This is our answer. Our frequency is 0.001 Hz. MATLAB coding example 2. First coding. This is where we change the code. This one is used to clear windows when there is coding used before this and close all the output graph produced by the MATLAB. Second one is used to plot the time and equation for the signal. Third, for the signal to be compressed by using the MU law of one way of quantizing value use. Lastly is used to plot the graph and to plot x and y used to encoding and decoding. This is our MATLAB coding. When we press enter, automatically the result will pop up at the display. We can see this is our graph. We have two graphs. We can see the difference between these two. This is for question 2. Generate a 2 kHz sinusoid with a peak-to-peak 2 volt and generate quantized signal when n is 8 and n is 16 levels. Calculate the signal to quantization noise ratio. Question 3 is use the MATLAB simulation for the question 1 and question 2. Then we simulate using the MATLAB. Then we adjust. Then connect. Then it will pop up our output. This is our output and we need to adjust. We need to find the curve point. This is our result. We do the same thing, that is, we need to connect. Then we change the frequency to hertz. Then we change the period second and pulse width. This is our graph output for example 2. Our conclusion is we're able to plot the PCM signal using MATLAB. We're able to understand one of digital model